Bismillahirrahmanirrahim. Good afternoon, guys. Let's start with lecture 6, number 6, part 1. Here at this lecture, we will focus on the ultrasound device. But at first, we will take simple information about what is the sound wave, what is the basic information to sound wave. After that, we'll focus on ultrasound device contents. Let me start from the first one. In my opinion, this lecture will be easier than the others because now you have some basic information about how these machines work, because at previous lectures we was talking about ECG and other devices in medical department. We will focus on sound wave, history of ultrasound images, ultrasound machine, what is the sonar machine, let me say, ultrasound device contains, comparison between X-ray and ultrasound machine. It's important. Why? Because I take some questions from this comparison, because that it will be important. Actually, in your PDF, I give it as a homework, but in this video, I solved it. The last point is reflection at boundaries. Let's start from sound wave. It's linear or non-linear wave. Actually, it's linear wave. Let me say a sound wave is a pattern caused by what? Caused by movement of energy. This energy traveling through a medium. That's mean the sound wave need a medium to can move, to can jump from the source to your air. Okay, this medium such as what? Actually gas, can be gas such air, can be liquid as water. That means the sound can move inside the water, yes, and you have experiment, you will take it at near future to prove that, and it can move inside the solid material. All of these three situations, material can move, the sound can move from all of these, and I give the appropriate examples. As it propagates, go away from the source of the sound. We have 2 points. The first one is the source. The second one is your air. But between these 2 points, we have necessary medium to give opportunity to the sound to can jump from the source to your air. Okay, this pictures illustrates to us the difference between the sound waves and visible light waves. Okay, it's very clear here. It's change from the source to your air by longitudinal waves. Longitudinal waves, that means like that. And the visible light, it's move from the source to your eye, such as waves, alternating current waves. Okay, transverse waves. Sound waves fall into 3 categories. We have 3 kinds of sound waves. We will focus on the first one, longitudinal waves. Second, mechanical waves. The last one is pressure waves. Here, mechanical vibration, like the previous lectures when I illustrate how the sound wave move from the source to your air, mechanical vibration will be what that's mean. Here, let me use the mouse pointer Here we have some distance between the sound waves, but the situation here is different. Why? Because the distance between these few sound waves, it's smaller than the previous. Okay? That means we have mechanical vibration sound waves transmitted through an elastic medium. Like I said before, this medium can be gas, liquid, solid. When propagate through air at appropriate hear frequency, produce sensation of hearing. That's mean when we note increase and decrease sound waves, that's because this vibration, that's because specifically between the distance between these horizontal lines, here it's bigger, here it's smaller. Focus on that. And A, B, it's are good pictures to illustrate this phenomena to us. Compressions and refractions that constitute a sound wave. Compressions and refractions. These two phenomena about bigger distance and smaller distance, we can say to the compressions and refractions between the sound waves. That's the main reason we hear increase and decrease in sound waves from a specific source. Here, let's take a simple idea about the ultrasound image from the sonar. At 1942, first application of ultrasound in medical imaging. It was not clear, but it was the first step to take good image in soft tissue, internal organ, a baby. The first step started from this year, 1942, end of 1960s, boom of ultrasound in medical image. Here we can image this picture twice to a baby. 1970 grayscale static images of internal organs. Mid of 1970s real-time imaging. At 1980 Doppler effect. It's another scanning machine. It's more development device, more development machine than ultrasound machine from the sonar, I mean. Here now, let's go deeply about our topic. What is the ultrasound machine? Now we have a simple information about the sound waves, how the sound wave can move from the source to your ear. Now let's talk about the ultrasound machine. Let's say between two brackets, the sonar. Ultrasound is an imaging test that uses high frequency waves to create real-time pictures or video. Here it's a unique different from X-ray. Here can dealing with pictures or videos, but at X-ray it was focused just on picture of soft tissues inside your body, such as internal organs or other soft tissues such as blood vessels. Blood vessels, it's a good example to the soft tissues. It's very sensitive device, can image very soft tissue to us in your body, such as blood vessels. It's unlike X-ray, but why? Because X-ray depend on radiation. At sonar, at ultrasound image, it depends on different things. This is high frequency sound waves. Ultrasound enables healthcare provide to see details of soft tissues inside your body without making any incisions, and that means without any blood, without any bleeding, and for many different situations, and to look at several different parts of the inside of your body. And let us don't forget, it's very commonly using with pregnancy to take the different times to develop your baby from the first few months until before he or she coming. It's very commonly using. Here, it's such as a homework, sorry, but here I solved it for you because it's important in the exam. X-ray machine, use radiation here, like I said before, use high frequency sound waves, just pictures, but here the situation is different because it can deal with pictures and videos. Dealing with bones, just with bones, here dealing with the soft tissue and internal organs. Ultrasound defined contents. Let's think about that, how this works, how this machine works, dependent on what? What is the ultrasound machine contents? At first, from this picture, we can imagine the first thing, the first content to this ultrasound machine is computer, screen, and these two handle things. This is probe, or you can say transducer, but probe, in my opinion, it's easier. Probe that is used to do scanning, the screen, computer, probe, and the last thing, piezoelectric. Piezoelectric. Let's think about that. What is the piezoelectric? Where is the piezoelectric in the ultrasound scan machine? How it's work? What its benefits? What is the piezoelectric? From what is made? How it works? Let's try to solve all of these three questions. Ultrasound device contains the probe and the PZT, piezoelectric, I mean. The most important component, this probe is the most component part in this ultrasound scanner machine. Why? Component of the probe is a thin piezoelectric crystal or material. Here we have a material inside this probe. This probe uses a piezoelectric to generate, it's important, and receive ultrasound waves. That's mean this computer, this machine, sorry, contains from computer, screen, probe. And the last thing, the piezoelectric PZT, is the most important thing. It's inside the probe. It's generate the ultrasound and receive the ultrasound waves to the specific parts on your body. You want to test it. Okay? Here, by apply a different potential, this piezoelectric start to vibrates to generate sound wave when applied with a voltage. Currently, the most widely used piezoelectric material is lead, zirconate, titanate, PZT. It's a specific material, specific construction, and the ultrasound device, and it's commonly used. This component, this structure is zirconate titanate. Zirconate, titanate. I hope it was right pronunciation to these two words. Actually, now we have another design of the ultrasound device. Actually, like I remember, we have two kinds, but here it's generally picture. Let's take generally idea. The law of optics to ultrasound. How the probe send the, let me think like that, how the probe can send the ultrasound waves to your specific soft tissue. Okay, we said piezoelectric, by applied different potential, start to vibrate, that means to generate the ultrasound waves and receive it. But how it receives this ultrasound? The answer will be from this slide. At title, reflection at boundary. The law of optics to ultrasound at the boundary between tissues. Ultrasound is partially reflected, like that. Here it's received waves, here it's reflected waves. Something like two ways, go and come. The relative energy reflected and transmitted depend on the acoustic impedance, acoustic resistance, let me use a simple word, between the two materials. Here, the technique is like that. We have two ways, two arrows. First one here is the incident ultrasound waves. Second is reflected waves. Its direction from the soft tissue come back to the probe. First one from the probe to the soft tissue. Some of them will transmit it. Some of them will transmit it. That dependent on what? On acoustic resistance between the materials, because the boundary between tissues. Let me say that again because it's important. The transmitted waves and reflected wave ratio is dependent on the acoustic resistance between the two materials according to the boundary between these tissues. Here we have three situations, three kinds from reflection of ultrasound probe device. The first one is the stronger one. Why? Because this, let me say, whiteboard or just flat boundary like that. Specular reflection is the stronger one from the large flat boundaries. Here we have lines, smoothly lines, let me say like whiteboards. Most of the incident waves will reflect it to the probe direction again. Why? Because here we're dealing with flat boundaries with a smooth shape. Okay. Second one is the weak kind of reflection at ultrasound. We can say the diffuse reflection. It's dealing with two situations. With some angle, because that here we have some reflected, but out or far away from the probe. And we have another situation when we dealing with small structures, but it's not flat. We have some angles, we have some boundaries, we have some up and down points. It's the weak reflection. when we're dealing with two shapes like that. The last one is the weaker reflection ultrasound. Why? Because here we are dealing with very small particle size. We can say when use it to illustrate, to scan some service characteristics to the some structure contains from some material, magnesium, calcium, lanthanum, something like that. It's related with the physics and chemical department. Its name, relay scattering from very small structure. Relay scattering from very small structure. Its name is relay scattering reflection at ultrasound probe device. That's it, our lecture today. It's easy. Have a good day and see you at next lectures. Thank you about your watching, your listening. Have a good day.